Hi 5W, this week we're going to do, our maths focus is going to be on volume displacement. I know the word seems big and scary, but we're going to go through this process step by step so that hopefully you can understand it. Before I start, I just want to show you, you told me that you wanted me to start with something funny, so I thought I'd show you a video of something Banjo did while I was making this video. This is just a very quick video of Banjo drinking the water that we're supposed to use for our volume activity. It just doesn't stop. The volume has gone down quite a lot since he started drinking. Just still keeps going. Thirsty, mate? Hey? What's going on? Are you nearly finished? Come on, hurry up. I've got no water left now. You finished now? Come on. Come on. Let's go. Come on. Come on. Come on. Stop it. Alright, say goodbye. Say goodbye. Bye-bye. Alright, so the normal way that we would usually figure out volume is to do length times width times height. So if we had a question that was like this, we would do 3 centimeters times 5 centimeters times 2 centimeters, and we would come up with the answer of 30 centimeters cubed. Now, this is about normal ways of figuring out volume, but what happens if you get a shape that isn't regular? So these shapes here, because they're straight lines and that they're like a rectangular prism, they're quite easy to find the volume of. But if we did have a shape that wasn't like that, what would that look like and how would we find the volume of it? Here are some of the objects that we might talk about if we're trying to find out the volume of. If we had an object like a toy, like a dinosaur toy or a Thomas the Tank Engine toy, or we had rocks or marbles, how would we find the volume of them? They don't have length, they don't have width and height the same way that a rectangular prism would. So how would we find this out? This is where we need to use the volume displacement method. Volume displacement is actually quite an interesting and quite easy concept to understand. Basically, the concept of my excellent drawing that you can see here of the boy or man or whoever trying to jump into a bath is trying to show that if you had the bath and the level of the bath was up to about here, and then the person jumped into the bath, what you would see was the water level would rise, because the person who is going into the bath weighs quite a bit, so the water level would rise. Now this is called volume displacement. It's about when you place something in water, the volume level rises, and this is how we can figure out the volume of these shapes. If, for example, another example would be if you put the object of the Thomas the Tank Engine toy into the cup, the volume would rise. The volume would rise. Now what we need to do to find that is we have to find out what the first level of the water was, and then we find out the second level where after we put in the object, and then if we take them away, we'll find the answer. Now this isn't explained very well, so I'm going to show you a quick video of how I could explain it a little bit better. Okay, so with the water displacement method, what we need to do is we first need to fill up the cup with water with a measuring cup. If you can see on this one, even though it's a mirror image, you can see that it says it's 240 milliliters, and we measure that before we start. Now after we've finished measuring it, then we take the irregular object that we need to measure, which in this case is going to be a rock, just any sort of rock, but yeah, it's an irregular shape, and then we're going to place that object into the cup, and then what will happen is the water will rise. So once we put this in, what you can see there, if I hold it up to the camera again, is just under 300 mils. So we started at 240 and now we're up to just below 300. So that means that I think it's about 290. So that means that the volume displacement method shows that it's gone up by 50 milliliters, which means that the volume of this irregular shape is 50 milliliters. So you could use this with lots of shapes, lots of different irregular shapes, and then you have to measure the volume before you put in the shape, or the object, sorry, and then you measure it afterwards, and then you subtract the difference, and that is the volume of your shape, or object, sorry. So I hope that's given you a better idea and an understanding of what water displacement is. So once again, as you can see here, it says you can measure the volume of irregular objects by measuring the amount of water in a cup, placing the object in the cup, and then measuring the water level again at the end, and then you subtract the one at the end from the one at the start. Now the difference is the water volume displacement, is the volume of your object. So as you can see down in the picture below, you can see this object here, and then we've got a cup that's filled up to the number, a cylinder that's filled up to the number 7. After that object is placed inside the water, the water level has gone up to number 9. So we started with 7, and now it's gone up to 9. So if you subtract 9 by 7, what you can find is the volume of that irregular shape here is 2. Now they haven't given it, so let's say 2 milliliters. So that is volume displacement. I hope that's given you a good understanding. Now, if you have a measuring cup at home or any other objects that you could measure things with, it'd be great if you could try this out at home before you come to class so you can get a good idea of how you can do it. So if your mum or dad have any cooking implements and they have some measuring cups, you might want to put a few different objects. Make sure they're sensible objects before you throw in iPhones and things like that. And you might want to measure how much the volume each of some of those irregular shapes has. So remember what we talked about. You measure it at the start. It doesn't matter how full it can be. It can be half full. It can be a quarter full. And then you need to put the object in. Now the object needs to be completely in. And then you measure it again at the end. You subtract the difference, and that's your volume. Okay, so remember, if you have any troubles or you can watch the video again, or you can ask me in class. Make sure you always can watch the videos as many times as you want. I know it's great to hear my voice. If you miss me, you can just watch it over and over again. Anyway, and then once again, any comments or questions you have about them, make sure you come and tell me. Otherwise, I'll look forward to doing the lessons in class. Bye!